Hi everyone, how are you all doing? I hope you're having a fantastic time in Kiev. Unfortunately, Google has issued a policy where we should not be traveling during the corona outbreaks, and as we had one case in Zurich specifically, who knows, I might be infectious. So I had to stay home, but that does not stop me from actually sharing what I've got to tell you. So let's jump right in. Today I'd like to talk about how Googlebot renders the web, and that specifically means we're going to focus in on how Googlebot, which is the crawler and rendering infrastructure that we are using for Google search, understands what a website is about and actually produces the website as the user would see it in a browser, and then uses that for search engine indexation. Cool. So specifically, I would like to talk about what is rendering anyways when we talk about rendering, because rendering can mean a few different things, and I mean one very specific thing when I talk about this in this talk. Also, we're going to look into our web rendering service, which is the component of Googlebot that actually is dealing with rendering the page so that the page can be indexed in the search index for Google search. And last but not least, I would like to part with some tips and tricks, and there's a few things to watch out for, and there's a few resources that I'd like to share. So, what is rendering? Well, as I said, there's a few different definitions of what rendering entails, and it depends a little bit on who you ask. So rendering can mean, or the question of how does your website or web application render? I mean, does it use server-side rendering? Does it use client-side rendering? But when I talk about rendering in this talk, I talk about the process of turning hypertext that is sent to a browser into the pixels that appear on screen. However, for Googlebot and Google Search, we actually don't really care about the specific pixels, but more on that in a moment. So this description is not really helpful, is it? I said turning hypertext into pixels. But what does that entail? Well, let's look at how a browser actually gets 2 pixels on the screen if you open a website. So I'm opening a website, let's say example.com, and the window opens, and now we have to wait for the server to start. So we've sent a request to the server, we have to wait for the server to respond to us. As the response comes in this case HTML streams in, we know, okay, so this is an HTML document and we're not having anything else, so an H1 can only appear in the body, so we can immediately like plop that on to the body. So here we have an H1 element and it has some text inside, in this case Hello Kiev. As more HTML comes in, as the server sends this into our browser, we can continue parsing. In this case we have a paragraph element and again some text in it, and then we have one more paragraph element and we have some image in it. And now we're done. That's it. That's the entire website. The website has been transferred and we have an understanding of its structure. We have parsed the HTML. And this is actually a really great advantage of HTML. You can parse it as it arrives. It can be progressively parsed. So as the data arrives from your server, we can start to actually create this DOM tree representation, this document object model, where we understand in memory what is on this page. There's a body, there's a headline, there's a paragraph, there's another paragraph. In that paragraph, in the second one, there's an image as well. Cool. But if I open a browser and go to a website, I'm not seeing that kind of tree structure. I'm actually seeing whatever the website is actually about, right? So something else obviously needs to happen. The very next step, taking this DOM tree as an input, would be to lay it out. What does that mean? Well, we have a certain amount of space, and this space depends on which device I'm on. It also depends on if I'm on full screen, if I move the window to a certain, resize the window to a certain size. So basically I have different amounts of space, and I somehow need to figure out how all these elements get onto that piece of space that I have, that is my browser window. On a phone, I have usually different space available than I have on a desktop computer, for instance. So we start going through this thing and we start, okay, so there's a headline. In this case, there's no CSS involved. If there would be CSS involved, we would have to parse the CSS as well into a different tree, which is called the CSS object model, and use that to actually figure out how the layout, how the dimensions of these bits and pieces look like. This is the default browser CSS, so a headline automatically is a block level element, so it spans the entire vertical space that the window presents, and it has a slightly bolder and larger font size. So here we go. There's like some box. We don't really have text in this one. It's just a box. We now know how large this box that is the headline will be, and how tall, and what kind of font we're gonna use, and what kind of font weight. So all the style information is now known, and we know how we can position that on the browser window. And we go on, paragraph, the same thing. It takes the entire space. And now we go into the next paragraph, do the same thing with the other paragraph as well. But we also have an image. Now, conveniently, we might happen to know the image size because it was part of the HTML. Or if it's not, then we can start downloading the image file, because most of the image formats have the size of the image in the first couple of bytes. So as the bytes arrive, we can figure out how large the image is going to be. And then we can put the image in there as well, which automatically makes the container, the paragraph, a little higher than it used to be beforehand. So basically, layouting is taking the DOM tree information and also the CSS object model tree information and figuring out how all these bits and pieces fit into a browser window, how they fit together, where we put them. But that's still not what I'm seeing. I'm not seeing a collection of boxes when I open a website. I see the actual content. So this looks more like the actual thing, but we're missing one step clearly. And the next step is we actually paint the things. So now we know where the boxes go. So we can actually start filling in the pixels. We can actually put colors on the screen. And that's exactly what happens here. In this case, we put the first element on the page and say like, okay, here's the text. We render the text onto the page. Wonderful. We do the next thing. We put the paragraph in here, and we put the image on the screen as well. And now that's the website as we see it. Googlebot does pretty much the exact same thing when it renders a website, except we are skipping the very last bit, because we don't really care that much about the actual pixels on screen. We care about the layer information. We need the layer tree, the render tree. We need to know where things go, how large they are, and where on the page they're going to be. We don't really care about the pixels specifically. So we actually skip that last bit and just use the layouted render tree. How does that compare? Well, if you're looking into your developer tools, you're probably going to see that layouting and actually executing a JavaScript is probably taking up most of the time. Painting can get quite expensive, but we would skip it anyways. And also, painting can be more expensive if you do not have a graphics processing unit. If you do not have a graphics chip that's specifically made for painting things on the screen or on a canvas, it might be a lot slower. So we're just going to skip that. We don't need the pixels. But we are not done yet, because as you might know, there's a possibility to actually use JavaScript to change the DOM. And that's pretty much what all our single page applications do. Unless we server-side render them or pre-render them in some way, then fundamentally what they do is they use JavaScript and change the DOM. And there's many different ways of changing the DOM. I can change existing content, I can add content, I can remove content. The sky is the limit. The DOM is completely under the control of JavaScript. In this case, for instance, I might just get some API response and then create a bunch of list items and then put these list items into the product list and then add this list entirely to the body. Which means that something as simple as like a very tiny DOM can become a more complicated DOM or a larger DOM. Especially when you're entirely client-side rendering, then you might basically have a DOM that has the body and maybe like one or two container elements, and then it loads all the scripts, and the scripts generate the entire rest of the DOM tree that is used to then lay out and render the page. So how does that actually look like when Googlebot does it? Well, to understand how we're doing this, it's probably good to understand how Googlebot generally is laid out. And Googlebot is not one program. It is basically a bunch of smaller programs that talk to each other. And these programs that talk to each other can take a bunch of different steps. So the same website sometimes might go one path through them and sometimes might take a different path. And for instance, what happens if fetching goes wrong? If we get a network error because your server was down, well, we're going to retry, and then we fetch a second time, we get the response from your server, and then we render. Or rendering fails for some reason, well, then we have to re-render, and so on and so forth. So it is not really a one-step operation. It's not like URL goes in, rendered HTML comes out. It is a little more complicated than that. And there's a ton of different bits and pieces. that are part of Googlebot, and this is not a full picture, this is just a small excerpt. So here you see a few of the services that talk to each other, things like duplication elimination. We have the actual crawler that makes the communication happen between your server and Googlebot. We parse links from the HTML so that we can crawl those. Web rendering is one bit of it. We have robots.txt parsing going on. We have to parse different kinds of contents. What if it's a PDF, for instance? Well, then we have to understand PDF and transform that into something that we can then index later on. So there's a lot of different services. There's so many more services than just this. There's also like spam detection, all sorts of that kind of stuff going on here. Today we're entirely focusing on the web rendering service. So we ignore everything else. We just assume Googlebot has a way to actually get content from your website respecting robots.txt and all that kind of stuff. But today what we want to do is we have made a request to your server. HTML has come back. Now we want to figure out how we can get the result of your JavaScript web app running to make basically progress in the Googlebot infrastructure with the website as the user would see it, because that's our goal, right? So very, very basically, the way that this works is that we get some HTML that was fetched from your server during the crawl time. And then we load all the resources it pulls in, so all the JavaScripts, all the images, all that kind of stuff gets loaded now. And then we wait until the page is done. And then we get the DOM tree, and then, or actually the render tree, and then we can push the render tree forward to go into indexing and understanding what is the content of this page, what is this page about, and so on and so forth, and actually land the page in Google search. Now, that is great and lovely, but it's a little more complicated than that. So let's assume we would use Puppeteer, which is an open source way of basically using headless Chromium. Let's say we use Puppeteer to build our own our own WRS version, okay? Now we need a browser, sure. So we get this Puppeteer instance of a browser, and then we open a new page in it, and then we might set the viewport, but that's already an interesting question. What viewport do we set this to? Do we say, I don't know, 1920 by 1080, but what about mobile? What if the website has different content if I'm on mobile? That's the reason why we have different Googlebot agents. One is the smartphone agent, one is the desktop agent, for instance. So we have a desktop bot and we have a mobile bot. That is one difference there. But we also do like all sorts of interesting things with a viewport. But let's, for the sake of simplicity, say we just figure out some window size that we're going to use for actually crawling and rendering your page. And now we actually open your URL. And we specify a timeout, after which we just say like, this is it. But in reality, that is harder. Because what if I say, I don't know, 5 seconds is the timeout? Yeah, but how many websites do you know that do not finish rendering after 5 seconds? A lot. I know a lot of websites that take longer than 5 seconds. So do we say 10 seconds? But how large is the percentage of websites that need 11 seconds? So we can't really just specify a timeout. So what we do instead in WRS is we use a few different heuristics, and we actually look at the event loop and stuff like that. But basically, you need to figure out a metric to figure out when the website is done and when you should cancel it. What happens if there's an infinite loop? You can't really wait for an infinite loop. You have to figure out some cutoff. We do change the cutoff every now and then based on real-world websites, so I can't really say a number after which we cut off rendering. But rest assured, we're doing our best to render your page. Just make sure that it's fast and doesn't take ages, okay? We also can say like, okay, so sure, we can look at the network, and if you're not fetching anything from the network anymore and the JavaScript event loop is empty, then we can assume that we're done here. So we're looking at different factors. Last but not least, all we need to do is basically just get the HTML that is displayed in the browser. But again, that is not very easy. This looks simple here, but this has a few really important drawbacks. The way that we're doing this here is problematic because it does not see what is inside Shadow DOM. If you use web components and your components are using Shadow DOM to display any important content, then this content would be invisible for us. So we have a different way of actually getting the HTML out that the browser has rendered and shown. So we do support Shadow DOM content, but be aware that if you try to build your own rendering service, it isn't as straightforward as it looks. Because, I mean, if you look at this, this is probably what I would have written if I would have written this web rendering service myself, I don't know, a few months ago or weeks ago. Because at very first sight, you're like, oh yeah, sure, I just get a Chromium instance, I set the viewport to some reasonable amount of screen estate, I open the URL, I wait until it's done, and then I get the HTML that the browser sees. It isn't as simple as that, it is a little more complicated. So what we do instead is we're not actually calling the web rendering service directly. There is a certain intermediate layer. This intermediate layer is called the service wrapper, and it has things like caching, for instance. So there's a cache service so that we don't have to always fetch things from the network, because network is very, very slow. And if we are trying to render trillions, billions, millions of pages, it's just, we have to make sure that we are as fast as possible. So we can't just rely on the network. We are also using aggressive caching strategies. And there's like so much more that goes into this. Also, if you are using our testing tools backends are actually talking directly to the web rendering service. But why not through the service manager? Well, the service layer actually would include caching, and when you run live tests, we want you to see what we would see if we would not have anything on the cache. So we are basically just directly going into the web rendering service when you test things, because we have to be quick and swift, and we can't just like wait 12 hours. You're sitting in front of a testing tool, you click the button, say like inspect or whatever, and then you want the data back. So we do not use caching there, and we do not wait very long. So the testing tools are a little less patient than the actual Googlebot is. But they are using the real infrastructure, so don't worry about that. So in order to make this as efficient as possible, our renderer, or the rendering service itself, has a bunch of components. And one of them is the headless Chrome instance that actually renders your page. That is an evergreen Chrome. We're updating to the latest stable version every couple of weeks after the actual release. So whenever a new version of Chrome comes out, very shortly after, Googlebot uses that latest version of Chrome, which is fantastic. But in order to not always have to start a browser, visit and render a website, kill it again, and start a browser again, we have a pool of browsers. Now this pool of browsers needs to be managed, because sometimes one browser might have a problem, it might crash, it might hang. So the pool manager manages a bunch of different Chrome instances where we can distribute the render jobs to. So we have a bunch of Chromes running, and they get basically health checked and made sure that the rendering works out well. And if one browser crashes during a render, then we try a different instance, and so on and so forth. And that is dealt with a web rendering service through a thing where we call orchestration. Also, we are instrumenting the Chromes. So that means we are basically running custom code, or plugins if you want to call them that, so that we get to change certain behaviors. I'm going to explain that in a while. It is not 100% a normal Chrome for obvious reasons. We don't support certain things, we can't or don't want to do certain things. So for instance, cookies are a fantastic example for that. Our Chrome instances do not save cookies. The reason being that when a user comes to your site through search, they might not have any cookies, so they might not have been on your website before. So if we are honoring cookies, then we might see a different piece of content than the user would actually see, and that isn't exactly great. So the way that we deal with that is we're not saving cookies. More on that later. We also collect a bunch of metrics. As you know, when we rank websites, there's hundreds of signals that we use for that. And these signals can be sometimes also generated throughout rendering. A bunch of them are generated throughout indexing at other points, but we do gather signals from rendering, which is quite nice. So we have a piece of code that does metrics collection here. This is, by the way, how web rendering service sees the website in the end. We see the tree. In this case, there's a bunch of tree nodes. Here's the H1 node, there's the text node that is part of the H1 node, and so on and so forth. So we actually do have the tree in memory and use that rather than the pixels, because this is more structured information that tells us a little better how the rendering data would look like. There's also information, this is just a shortened version of this, I can't fit the entire thing on the slide. There's also things like where on the screen is it overlapped by something. There's a bunch of information that we have in this render tree. As you can see here, there's the X and Y position, for instance. There is which piece of style node is taken from the CSSOM, and so on and so forth. Again, this is a shortened version of what we are using. Cool. Now, what happens in the renderer? Well, first things first, as I said, we are not really saving cookies. If you test this, you're gonna see that if you have a website that writes a cookie, does something else, and then reads a cookie, that's gonna work. But if you have one page and another page, page A writes a cookie, page B reads the cookies, you're gonna see that even if we visit A first and then go to B, we're not gonna have the cookie when we visit page B. So cookies between pages are being cleared. They are not available. We actually overwrite that specifically. Also, our date and time functions might show different data. So for instance, if there is a little bit of time between crawling and rendering because there was a problem with rendering or something like that, or we re-render pages sometimes without recrawling them necessarily, then we might use the crawl date rather than the real date. So you cannot really use date and time functions to understand how Googlebot actually proceeds through time, because you might get really weird results where it's like, oh, but hold on, today I got the date from yesterday, but or earlier today I got the date from yesterday, and now when I do it again I get the today's date, and it's like, yes, because there was a crawl in between and now we crawled again today, so that's why you're seeing a different date. So don't rely on date and time functions to show you what happens inside Google search. We do not register service workers. The way that we avoid registering service workers, similar to cookies, service workers can change the behavior of a website once I have a repeat visit. We want the website, or we want to see your websites as first-time visitors would see it. So whenever you're trying to register a service worker, we are rejecting that. That doesn't mean that you are on like seeing a really old weird browser doing it. It might just be Googlebot trying to not accidentally install the service worker. So do not rely on service worker registrations to always work if service worker API is supported. It can be rejected, and we do reject it. The same goes for all sorts of permission prompts. If you try to access a webcam, push notifications, geolocation, whatever, there's a permission prompt in your browser, we are rejecting these things immediately. Like, we do not hang at the permission prompt. We don't even get to the permission prompt because we reject it right away. So you would see the error code triggering in that case. Also, the goal of the web rendering service is to have as repeatable renders as possible. So that means we always want, if the same data comes in, we want the same data to go out. We want the renders to be as consistent and deterministic as possible. In order to do that, we might disable random in the way that we do give you random numbers, but they're always the same. They have a fixed seed, and they always are the same numbers. We sometimes render without that, but we can enable it. Some renderers will probably not be random. So don't rely on random too much to be actually random when you need it for, like, I don't know, generate content or something like that. Googlebot will probably use similar values or the same values over time. There's also a way of how we are rendering animations that is sometimes a little confusing when you use our testing tools and look at the screenshot. Don't worry about the screenshot, care about the rendered HTML. We care about the HTML more than anything else. So don't worry about it, that animations might look weird in Googlebot. Cool. Now let's talk a little bit about misconceptions around rendering. And one of the big ones is that people say like, oh yeah, okay, yeah, Googlebot does support JavaScript, but it only uses a really old Chrome version. That is no longer true. We have discussed this. We're using an evergreen Chrome. The other big one that is still pretty popular is that people say like, yeah, but it takes a lot longer for Googlebot to actually render JavaScript. And I would like to clear that up a little bit. So there's two timings that people can look at. One is the queue time, which is the time it takes between us actually crawling and then us waiting for resources to be available for your website to be rendered with the web rendering service. And then there's also the render time, which is the time once it enters the web rendering service until it leaves the web rendering service, until we are done rendering, right? These two times often get mixed up. It's like, oh yeah, but Googlebot renders, like, okay, yeah, sure, this website takes 20 seconds to render in my browser, but Googlebot renders within 5 seconds. And it's like, no, if it takes your browser 20 seconds, it's gonna take us 20 seconds as well. So that's not gonna be faster. And then some other people are like, yeah, but it takes up to a week until you get rendered. And I'm like, yeah, no, not really. So let's start with the queue time. We measured and found out that the queue time at median is 5 seconds, which means within minutes we get to the 90th percentile. So we are pretty fast at making resources available for rendering. So your website does not stay very long between crawling and rendering. That is a very, very short amount of time. But the rendering time, we can't really make any statements on that much because it depends on how fast your website renders. If your website is really, really fast at rendering, we're going to be really fast done with rendering it. Yay. If your website takes a minute to render, yeah, then it takes a minute. There is no such thing as rendering budget. There's only a cutoff after some time. And again, I cannot say exactly what time that is because we do change this variable. But fundamentally, if your users are going to be pissed at waiting for your website to finish loading, you're going to have a problem with Googlebot as well. So make your websites fast and render fast, but don't worry too much about it. If it takes like, I don't know, 10 seconds, 30 seconds, you should be fine. If it takes you a lot longer, you definitely want to reconsider making your website maybe a little faster. And a lot of these misconceptions and misunderstandings come from the fact that you can't really observe rendering exactly. You see on your server logs when the crawler comes and fetches resources. But the fact that we fetch resources does not necessarily mean that we are also rendering immediately. It might also mean that we render again and then fetch resources again, and there's no crawl to the main HTML before that because there was something else in the pipeline requesting a re-render. So you can't really see inside of these parts of the pipeline. You can see in your server logs when the crawler comes in, and you can see from the index and from Google Search Console if your page is indexed and how it looks like in the index. But in between, there's a bunch of stuff happening where you don't exactly know what's going on. So for instance, you might get rendered and then something else decides, oh, this page doesn't look like it has much content, or hey, this page does not want to be in the index or whatever, and then we throw it out of the index or we don't put it in the index in the first place. So you would never see it show up in the index. To say, oh, JavaScript and rendering is the problem is not quite right because a bunch of stuff is happening. So even if it's a static HTML page, it might go through the rendering stage. Nothing has happened, and just like the other part of the rendering pipeline says, oh, I don't think this is important, and then we're not going to index it. So it's not about JavaScript, it is just generally about the pages specifically. So it's very hard to debug this from your side, and it doesn't need your debugging. Normally the issue is with something else than just JavaScript, and you can use the testing tools. If the testing tools show you an error, if the testing tools show you that the content doesn't show up in the rendered HTML, and that's something to actually look into rather than worrying about like, oh, is it JavaScript? That makes everything a lot slower. That's a secondary concern, really. All right, now for the last part, I'd like to talk a little bit about like tips and tricks that I've got for you. So first things first, be very, very careful with your website wait. If your website is really slow, people don't like that. Also, Googlebot is not exactly happy with that. We are very good at caching a lot, so we have pretty good cache rates between 60 and 70% normally. But if you think about that, most websites are actually like fetching 50 to 60 resources. It is still quite a bunch of work that we have to do on the network. The fewer bits we have to do, the greater it is, and there's a bunch of strategies of making a website load fast. One thing is also you can help us cache things better by basically having very long cache runtimes. One way of doing that is to use like fingerprinting, or in this case, the content IDing. So the way that you do that is you build your code, and then as part of your build process, you basically just run an MD5 hash, or any hash really, on the content of that file, and you attach that to your file name. Because then you can cache this file forever. As long as it doesn't change, the URL is going to be the same. The moment you change something in the content, you're actually going to see that the hash changes, and then we're going to load a different resource. So you will support us caching things for a very long time, which makes us faster, and that's just good for everyone, really. Also faster for your users. So these content hashes, you can get them, for instance, with Webpack. You can say like, yeah, sure, I want this lovely content hash in my files when I create the output file, and then you get that for free. And then in the HTML plugin, it actually substitutes the content hash properly. So that's not a problem. Also, Just generally do not fetch as many resources, maybe. So if you can avoid that, that is fantastic. So here, for instance, we are loading some jQuery version and then some other jQuery version and then some preview.js thing, and I don't know. Maybe we can kick a bunch of this out and then actually just load fewer bits and pieces. And we can also do that by bundling together our code. So if you have an application, you can probably try to figure out like what can go into one file and where can I like bundle things up so that I do not have to do as many fetches. That is great, but it comes with a downside. So we do have less requests, but it also means that when anything changes in this bundle, the entire bundle needs to be re-downloaded. That's not great for caching. It also means that when I go to one page, I download the entire code for everything, and I might have to re-download that again if I go to a different page. That's not great for your users, that's not great for Googlebot. So you only have one large bundle when you do that. That's not super sweet. In which case, ironically, there's an option to say, hey, maybe I'm gonna split this into multiple bundles where it makes sense. If you do that in Vue.js, for instance, in your routing, you can say, so I want to import this component for this path and this component for this other path. Then you actually end up with multiple bundles. And that's pretty nice. You can also say like, okay, so what is shared across every page? So let's say like you have a bunch of common JavaScript code that is used on every page. You can put that in a separate runtime bundle, and then you can cache that again. So that means that we would download the runtime bundle, the first page, and all the other bits and pieces for that page as well. And then when we visit the next page, remember, Googlebot does cache things. So the runtime bundle hasn't changed, and we know that the cache policy allows us to just use it again. We're just going to use this again, so we don't download this again, and we only download the bits and pieces for the other page that we don't have yet. That allows us a lot more flexibility and allows you to build things that are faster for your users as well. And better for your users is the goal for Googlebot as well. Anything that is good for your users should be good for Googlebot. So let's recapitulate. Rendering fundamentally is the process from HTML going to pixels. Asterisk here is that Googlebot stops one step short and we don't actually render the pixels. Part of the indexing pipeline calls the web rendering service, and that is the bit that actually renders the website in Googlebot. And yeah, WRS does not need the pixels, it uses the other thing. And the way that it's called is to the service wrapper, and the service wrapper also embeds a cache. So we do aggressively cache. That also is true for every kind of GET request that you do. So if you do API requests, we might cache the API response too. Just use good best practices for web development these days. That means bundling things, minifying things, splitting your code, tree shaking, removing everything that is unused from the libraries you are importing. So basically producing as small bundles as possible and as few bundles as possible, but reasonably split so that you don't actually load unused code when you don't need it. And test your pages. You can test pages in things like the mobile-friendly test, or you can use the rich results test. If you go to Google, developers.google.com/search, you find a lot of documentation that explains this. And if you go to youtube.com/googlewebmasters, then you're actually going to find our YouTube channel where we explain things even more. And with that, I'd like to say thank you very much. And remember, as everything in software development, it depends is the answer to most of the questions. Bye!